But what you can learn from the periodic table is endless! Just kidding. There are just a few trends that can help you find what you're looking for. Stay tuned for atomic number, atomic mass, reactivity, electronegativity, ionization energy, and atomic radius, and how to find them on the periodic table.
The elements are organized by atomic number. Starting with hydrogen, which has an atomic number of 1, each element has one more proton than the element before it. This means atomic numbers increase from left to right across each period. Super easy, right?
Well, atomic mass does the same thing. Atomic number and atomic mass sort of go together. Think about it as a nucleus gains protons. It gets heavier. Atomic number and atomic mass follow the same pattern, increasing across the table and from top to bottom.
So that's the nucleus. But what about the whole atom? Atomic radius is the distance from the nucleus to the outer edge of the electron cloud. It's hard to measure exactly because the electron cloud isn't well defined.
Scientists agree to use their best estimate of the size of the electron cloud.
Atomic radius decreases from left to right on the periodic table and from bottom to top within each group. Just remember, the more electrons there are, the bigger the atomic radius.
So, you know how some people are just easier than others to get a reaction out of? Well, elements are the same way, and trends in the periodic table show us which ones have tempers and which ones go with the flow.
Reactivity is the willingness of an element to combine with other elements and form something new. Sometimes an element is so stable that it totally ignores other elements. The noble gases are especially famous for their stability.
Quite right.
Nobility and stability go hand in glove. England!
Soul, Britannia, Britannia rolled away.
Other elements are so reactive that a meeting with another element is a recipe for fireworks. The most reactive elements are at the upper right and bottom left corners of the periodic table, except for the noble gases. The elements in the middle of the table, like gold and copper, are also super stable. Like the noble gases, almost nothing riles them up.
The most reactive elements live in opposite corners because they're totally different kinds of elements. Reactive metals hang out in the bottom left corner, while really reactive non-metals gather in the upper right corner.
Okay, so some elements react and some don't, but why?
Well, reactivity is caused by a couple of trends working together. The most important ones are electronegativity and ionization energy.
Electronegativity is an atom's desire to steal electrons from other atoms. Strongly electronegative atoms are more likely to pull others into chemical bonds, and another name for a chemical bond is a chemical reaction. Not all elements have the same amount of electronegativity, which is where the table comes in. The elements in the upper right corner have the strongest electronegativity, so they tend to pull neighboring atoms toward themselves. The elements in the lower left corner exert a weaker pull. Keep in mind that the electronegativities of the noble gases are unknown, since they hardly ever bond with other elements. They hardly ever bond with anybody. They hardly ever bond with anybody. The other trend that makes up reactivity is ionization energy. Ionization energy is like electronegativity's crazy twin. Remember, electronegativity means that an atom pulls inward. Well, ionization energy is the energy needed to pry an electron away from its nucleus.
On the periodic table, ionization energy acts like electronegativity. Think of it this way. An atom that pulls electrons towards itself also puts up resistance from having its own electrons removed. That's why the two properties go together.
When electronegativity and ionization energy team up, they tell each atom how much it wants to bond with other atoms, which we call reactivity.
Whew, that's a lot to take in. But remember, the table is there to help you. It's like a gold mine of information, so don't be afraid to use it. Or maybe it's a silver mine, or a beryllium mine, if beryllium comes from a mine. Anyway, just use it.